Chapter 12, Lesson 2 is about square roots of products. We're not exactly multiplying in this lesson, but we are going to be learning something called simple radical form. And it's a very important lesson for you to learn. So here we go. Isaac Newton is actually the guy, Sir Isaac Newton, who came up with the idea that x to the 1/2 means the same thing as the square root of x. And he went through this little process, which you can actually read through in our book if you'd like, that kind of tells you how he got there. But you just need to know that the half exponent means the square root of. In fact, the third exponent would mean the cubed root of, and the fourth exponent would mean the fourth root of. And we may do a little bit of that as we move further into the chapter, but mostly we're going to be concerned about squares and square roots. Now, in chapter 8, you learned the law of the power of a product when we dealt with exponents. And that law simply said that if we had something in this group of parentheses raised to an exponent, then the exponent related to both of those factors within the parentheses. Now, using Sir Isaac Newton's 1/2 exponent, we can write it as xy to the 1/2, which would mean that it could be the same thing as x to the 1/2 times y to the 1, or x raised to the 1/2, y raised to the 1/2, and it could be written as the square root of x times the square root of y. In fact, it can also be written as the square root of x times y. Now, this little definition here is important for this chapter, and it's important because we will be able to put things into what is called simple radical form. The square root of x times y is the same thing as the square root of x times the square root of y. And what that means is if we get a number like 200, we know we don't have the ability to take a nice square root of 200. It's just not an even or a perfect square. However, you can easily see that we could factor 200 into 100 times 2. And when we do that, then we could also separate it and make it the square root of 100 times the square root of 2. And we can take the square root of 100 easily. That's 10. And then we can put the square root of 2, keeping it in the house or under the radical, because we have no other way of bringing it out. This form, this expression, is called simple radical form. It's equivalent to the square root of 200, but it's a different way to write it, and for some purposes it can be a simpler way to identify the values of our square roots. So let me show you some other examples so that you get an idea of how to do these. If you had the square root of 48, maybe you can look at that and tell right away that that is going to be 16, I think, times 3, okay? And what you want to do is you want to think of factors of 48 that you can take the perfect square of. Some of them you'll look at and it will be easy to do. This wasn't that terrible. If I got 16 times 3, then I can rewrite it if I needed to as the square root of 16 times the square root of 3, which is going to equal 4, because that's the square root of 16, times the square root of 3, and that would be my final answer. Now, if you could not think of the square root, of 48 or factors of 48 easily, you could take 48 and you could prime factor it by just going, okay, well, that's 24, and 2 times 12, and 2 times 6, and 2 times 3. And then for every pair of prime factors you get, you can pull them out of the house. Okay, in this case, you could pull out 1, 2, and you could pull out another 2. 2 times 2 would be that 4, and then the 3 has to remain inside because it doesn't have a mate. Okay, now look at, now that I've messed up my paper, the square root of x to the 6th. Now, mentally, if you just always divide the exponent in half, by doing that, you would get x cubed outside. Okay, if you need a little Sir Isaac Newton to help you, then you can think of it like this, that x, the radical or the square root of x to the 6th is the same thing as x to the 6th raised to the half power. Okay, and obviously that would be the same thing as x to the 6 over 2, which is the same thing as x cubed. Okay, so that's kind of the mentality that goes behind it. And the rules of exponents that you learned in Chapter 8 wouldn't hurt you as well, but you're just dividing the exponent in half and pulling it out. Okay, now let me show you a different example. If we have 75x to the 7th, I know that I can rewrite 75 as the square root of 25 times the square root of 3, and I know that x to the 7th, it's not pretty. Okay, I'm going to write it like that. That's not pretty handwriting either. But I can take this square root, okay, I'm going to end up with the square root of 3 remaining inside. Okay, and x to the 7th, well, if I did x to the 7 divided by 2, I'm not going to get an even answer. I'm going to get 3 and a half. Well, the 3 x cubed can come outside. The remaining x to the half, or the square root of x, has to remain in the radical. So in simple radical form, 75x to the 7th equals 5x cubed times the square root of 3x. Now let me just give you a hint. Anytime, no matter how big the exponent is, if it is an exponent that is odd, when you divide it, you're always going to have one left over that stays in the house. But you should never have like x cubed or x to the 5th or anything like that in the house, because you can always get rid of some of them. So you should only have that one lonely leftover in the house. So I hope that you have somewhat of a grasp of how to deal with the product of a radical and dealing with simple radical form. Learn the terminology and have some fun.